Hello, today's video is going to be the first video in our unit on probability and statistics. Now, lucky for most of you, people that don't like math usually like probability the most. So this might be your least terrible unit that we do all year. The first section that we want to talk about is called the fundamental counting principle. So we're going to learn several new words today and their definitions, and they're all going to build up to some practice problems. So the first thing is the fundamental counting principle, and it says that if a decision M, so let's say that, choosing 3 marbles out of a bag is M. If decision M can be made M ways and decision N can be made N ways, then 2 decisions can be made M times N ways. This is going to make much more sense whenever we look at the examples. Okay, problem number 1 says, the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? All right, so this says that we have 3 choices of cone size, 15 flavors of ice cream, and 8 toppings. So this goes back to our fundamental counting principle. We have decision M, decision N, and let's say decision P, and they can be made little m is 3, N is 15, and little p is 8. They can be made 3, 15, and 8 ways. So if we need to make all of those decisions, then it can be made 3 times 15 times 8 different ways. And this number equals 360. So if there are 3 cone sizes, 15 flavors, and 8 toppings, there are 360 different 1 flavor, 1 topping cones that we can make. All right, so number 2 takes a little bit of intuition, okay? Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? All right, so we have to make a choice for every single position on a license plate. So there are 3 letters followed by 4 digits. So that means that we have 7 total spots to fill. So 1, 2, 3, 4, 5, 6, 7. Now, I want us to think about how many choices we have for each one. So the first 3 are letters. It says 3 letters followed by 4 digits. So how many letters what letters can we choose from? How many choices are there? Well, there are 26 letters in the alphabet. So we have 26 options for the first spot on the license plate. The second spot is also a letter. So we have 26 options. And the third one is another letter. So we still have 26 options. Now, how many different license plates are possible? I forgot to finish the rest of this. All right, so it says followed by 4 digits. How many digits are there? So each one of these is a digit, and we have to choose how many digits there are. So there are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 possible digits to choose from. And each one of these can have any 10 or any one of those 10 digits. So we are going to multiply all of these numbers together to get 175,760,000 different license plate possibilities. All right, number 3. Nick's science test has a section with 12 true or false questions. How many different ways can Nick answer these questions? Okay, so each question gets its own blank. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, these are true or false questions. So, how many options are there for each question? There are 2. So, there are 2 options for all 12 questions. Now, if we look at this, we could have said, okay, let's think about this. 2 times 2 times 2 times 2 times 2, blah, 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 blah. Well, when we multiply something by itself, we can use exponents. So since there are 12 2's here, we could have said 2 to the 12th power. So this is how many choices we had, and this is how many times we chose. So 2 to the 12th power is 4,096 different possible combinations in which he could answer these 12 true or false questions. All right, so the last one in this section is to enter their home, the Clayton family enters a 4-digit code. How many codes are possible? So we have to make 4 choices because we have to choose a digit for each of the 4 spots. So there are 10 digits. We decided that there are 10 possible digits, 0 through 9. So there are 10 choices for each of the 4 slots. And once again, we could have just said 10 to the 4th power. And that will equal 10,000 different possible combinations. Okay, so now that we have a little bit of experience with the fundamental counting principle, the next thing that we want to look at are called factorials. Factorials are the product, so that means multiplication, the product of all natural numbers from n to 1. And I forgot to write up here that a factorial looks like n exclamation point. And n can be any natural number, so counting numbers, not negative. Okay, so examples would be, all right, n factorial is going to equal 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when we type all that in the calculator, we get 362,800. So 12 factorial would be 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. But I'm going to show you how to enter this on your calculator. So we are going to do the 12 factorial on our calculator. So if you have a TI-84 or 83, or really most graphing calculators, you are going to use this math button to access different probability functions. But first we have to type in the number that we want to use. So we're just going to type in 12. And then we want to find a way to put that exclamation point in to say factorial. So we hit the math button right here. And you'll see that this brings up a menu. If you hit the left arrow key, it will take you over to probability, which is what PRB stands for. And then if you look, number 4 has an exclamation point. And so instead of scrolling down and hitting enter, we can just type the number 4 and it just saves you some time and some keystrokes. And you can see that this says 12 exclamation point, which is exactly what our problem says, 12 exclamation point. So when we hit enter, it's going to tell us that this is equal to 479,001,600. And I'm going to show you this on Desmos as well. So once again, just to clarify, that is math, and you hit the left arrow to go straight to probability, and then you hit the number 4 for the exclamation point. And this one, because I didn't type a number in, it put it in front of the answer. Let's see how big of a number that is. Oh, it's too big for the calculator. How funny. All right, so on Desmos, it is as simple as typing exactly what you see. 1, 2, exclamation point, enter. And there you go. It gives you the answer as well. So not difficult at all on Desmos, but on the ACT, for example, you'll want to be able to do it on the TI-84. So for 8 factorial, you can type that into your calculator and you should get 40,320. And now for this one, I just want to show you something about dividing factorials. So if we were to write this all out, we would have 17 times 16 times 15 and all the rest of these numbers. So I wrote it all out. You don't have to write this. I just want to show you. So when you have factorials divided, what happens is all of these numbers cancel. So 1 and 2, 3 and 3, 4s, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11. So what's left is just 17 times 16 times 15 times 14 times 13 times 12. So you can do it just like that. You can type all that multiplication into your calculator, or you can type it in just like this. So in Desmos, it's pretty self-explanatory, but on the TI-84, I wanted to show you a couple of things when you do the fraction. So in order to put a fraction in your calculator, there's a shortcut for the newer TI-84s that you press alpha, which is the green button, then you hit y equals up here, and then you press enter. So alpha, y equals enter. And now you can see that you have a fraction to fill in the spots for. So now you can type in 1, 7, and our exclamation point is under math, left arrow, number 4. And then go to the bottom and do 11, math, left, 4, enter. And we get 8,910,720. And finally, we have 0 factorial. And this has a star beside it because it is a special scenario. So from 0 to 1, there's really not anything. 0 times 1 would be 0. Like there's no good way to do this. But just as a rule, 0 factorial is always equal to 1. So this is a rule that you need to remember. Rule. Okay, the next thing we're going to talk about are called permutations. So this is a new word, permutation. Okay, I have done something weird for math class, right? I have put up here in the top the thing that you had in elementary school when you learned how to write your letters properly. This is the way that a line looked. So I just want to make sure that we know how to properly write permutation and combinations. Okay, so the a permutation is written as N, which is a subscript. That means it goes below the normal line. And then big P, and then a subscript R. This is a permutation. And N is going to be the number available, which we're going to talk about this in just a second. It's written on your paper if you have it. And R is the number you're choosing. And this is going to make more sense in a second. We're going to do it on the calculator, everything. But I want you to understand how this is written, because a lot of people will make the P be an exponent or something like that, and that's not accurate. So this is important to me that you understand how it's written. Okay, so back to math instead of spelling. A permutation, remember we're talking about probability. A permutation is an arrangement or a lineup of objects in which order matters. So, for example, if I asked you if there are 5 runners in a race and we want to see how many different ways they can get first, second, and third place, the order matters because if you pick a different one first, that matters. It's different. First place is a different thing than third place. So the order of the arrangement does matter. So the formula for a permutation is n factorial over n minus r factorial. And n is the total number of objects available. So in the example of the runners, it would have been the 5 runners. There are 5 runners available. And r is the number of objects to use for the arrangement. So we want to place 3 of them. So r would be 3 in that example. Now, an important shortcut. If you have NPN, so this means, let's say there are 5 runners and we want to place them 1 through 5, or 1st through 5th. So we want to see how many different ways can we place the runners, place 5 runners in 1st through 5th place. Then that would just be n factorial or 5 factorial in the example I'm giving you. All right, so our first example of a permutation is, how many ways can you arrange the letters in the word dinosaur? So first, let's talk about why this is a permutation. So if I choose the same letters but rearrange them into idnosaur, does that count as a different entry? Yes, it does. And that's a good way to check. If it counts as a different answer, then it's a permutation. So how many ways can you arrange the letters in the word dinosaur? So we need to decide what n equals. And n is how many options you have to choose from. So how many total letters are in dinosaur? There are 8 letters. Okay, now we want to know what r is, and r is how many letters you're choosing. Well, it wants us to rearrange all of them. So we have to rearrange all 8 letters. So our permutation is going to be 8p8. And if you remember, our shortcut says that this just equals 8 factorial. So we can type that into our calculator and we will get 40,320 different ways to rearrange the letters in the word dinosaur. Number 6 says 7 students are competing in a geography B. How many ways can they finish in 1st, 2nd, and 3rd place? So once again, this is saying 1st, 2nd, and 3rd place, which means that each order, so if we pick Joe, Susie, and Tom, and then we pick Susie, Joe, and Tom, do those count as different things? Yes, they do, because that means we had different 1st, 2nd, and 3rd place winners. So that's why it is a permutation. So n is how many we have to choose from. There are 7 students, so n equals 7. R is how many we are choosing. We're choosing 1st, 2nd, and 3rd, so we are choosing 3 students. So this is going to be 7p3. And, I could make you guys use the formula. The formula would look like this. It would be 7 factorial over 7 minus 3 factorial, which would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 minus 3 is 4. So 4 times 3 times 2 times 1. And then these would cancel. And we would get 7 times 6 times 5, which equals 210 different possible ways that they could be placed. but I would rather you guys just get used to using your calculator. So use your calculator. You do not have to do the formula. The problem with that is I haven't shown you how to use your calculator. Wow, I am so sorry. So let's look at how to use our calculators on this problem. Okay, so we already talked about where the probability buttons are. So they are under math, and then you hit the left arrow keys to go to the probability menu. And if you look at number 2, it says NPR. That is how our permutation is set up. So if we click on it and see what it looks like, it says answer NPR. That means that we should have typed something in before. So the proper way to do a permutation on your computer is to first type in your N value. So in number 6, N was equal to 7. So we're going to hit 7, then we're going to hit math, left, 2 to choose permutation, and R is equal to 3, and then we're just going to hit enter. And we get 210, which is what we got when we used the formula and did it out by hand. Okay, on Desmos, it's pretty simple as well, but I'm going to walk you through it once. So we want to use this keyboard icon at the bottom. We're going to click on it, and then we're going to click on the functions button. And when we click on that, it brings up these different options. And we want to click on stats because this is probability and statistics. And if you look down here, we have NPR. That is for permutation. And we put our N first, so it's always in the same order, N, then R. So 7, 3, and hit enter. And it tells us 210 different possibilities. Okay, so let's look at number 7 now. Melanie is taking 4 classes this semester. American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged on her schedule? So she is taking 4 classes, so we have to choose what N and R are. So N is how many possible classes? Well, she's choosing from 4. R is how many we're going to pick. We're picking 4. So this is 4P4, which is just equal to 4 factorial, which we can type in our calculator and find to be 24. There are 24 different ways her schedule can be rearranged with these 4 classes. So then let's look at number 8. There are 16 players on the baseball team. How many ways can the coach make a 9-player batting order? Now notice it doesn't say choose 9 people to bat. It says the batting order. So that is important to knowing that this is a permutation. All right, so N is how many you're choosing from. There are 16 total players. R is how many you're choosing. He's choosing 9. So this is 16P9. And when we type that in their calculators, remember if you have a TI-84 or any other kind of TI, you type the 16, then you hit math, left, 2, and then type in the 9. And for Desmos, you go to the keyboard, you hit functions, you hit stat, you hit NPR, and then you type in 16, 9. All right, so you should get 4,151,347,200 different possible batting orders from a 16-player team. All right, the last example for permutations is there are 28 students in Mr. Miller's homeroom. How many ways can the students elect a student council representative and alternate? All right, so they are choosing from 28 students. They are going to choose 2 of them. They want to choose a representative and an alternate. So this will be 28P2, which is going to equal 756 different possible pairings of students. Okay, so there are such things as permutations with repetition. And the way that this works is typically it means this only works whenever you're using all of them. So when N and R are equal to each other. So how many different 10-letter arrangements are possible using the letters in the word automobile? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters in the word automobile. So there are, and we have to arrange them we're going to use all of them. So remember that is equal to 10 factorial. But we have two O's. So since O shows up twice, we have to divide this by 2 factorial. And we're going to get that there are 1,814,400 different ways to rearrange the letters in the word automobile. And the reason we have to do this is because if we switch the 2 O's, that's the same result. It doesn't show us a different arrangement. It didn't change anything. So we have to take out some of those options because they're going to be repeats. Okay, if we look at number 11, how many different 9-letter arrangements are possible using the letters in the word disappear? So there are we want a 9-letter arrangement and we want to use all 9 letters of the word disappear. So we're going to have 9 factorial on top. But then we have to look at repeats. So the letter A repeats twice and the letter P repeats twice. So A is in there twice, so we have to divide by 2 factorial. P is in there twice, so we have another 2 factorial. So these are multiplied together. So if you have a newer TI-84, you can use the fraction thing and put it in here. If you have an old TI-84, you need to have N exclamation point parentheses divided by parentheses 2 exclamation point 2 exclamation point parenthesis in order to get the correct answer. And the correct answer is 90,720 different ways to rearrange the letters in the word disappear. Okay, so the other type, and this should go a little faster, is a combination. Combinations are written as NCR. So C for combination, P for permutation. And a combination is a group of objects in which order doesn't matter. All right, so the combination formula is N factorial over R times, R factorial times N minus R factorial. But we don't care because we're going to use a calculator. Okay, important shortcut. If we want to arrange N items if we want to choose N items from N items, then there is only one way to arrange them when order doesn't matter. Think of this as I have 3 dogs, but I only have room to take 3 dogs with me. Well, it doesn't matter what order I put the dogs in because I have 3 spots and I don't care who sits where. But I can only choose one group of 3 dogs from a group of 3 dogs. There's no way to redo that. So anytime you have NCN, it's just going to equal 1. Okay, number 12 says, Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? Now, this does not say how many ways can she choose the order of the bridesmaids. They just want to know how many ways can she pick 5 people to be bridesmaids. So if she picks Sally, Joe, whoever, if she picks 5 people and then she picks those same 5 people but in a different order, that does not count as 2 different answers. So that's why it's a combination. So this is going to be 16 because she has 16 friends. C, 5 because she's choosing 5 of them. And when we type this in our calculator, we do the exact same thing except in the TI-84, When you go to the probability menu, you choose option 3 instead of 2 because it is NCR. In Desmos, you go to stats in the functions and you choose NCR. And when you type that in, you are going to get 4,368 different possible ways she can choose 5 bridesmaids from her 16 close friends. Number 13, there are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So the order he chooses them does not matter. So we have 24 students, and he's going to choose 8 of them. And when we type this in our calculator, we should get 735,471 different possible ways that he could choose to invite 8 students. All right, Abby is adopting kittens from the pet store. If there are 18 kittens, how many ways can she choose 2? So there are 18 possible kittens. She is choosing 2. So we should have 18C, not R, 2. And that will give us 153 possible pairs of kittens she can choose. Number 15 says there are 12 employees at a sub shop. How many ways can the manager choose 4 for the Sunday evening shift? So no matter what order they pick them in, they all 4 have to work the Sunday evening shift. So there are 12 to choose from, and we're going to choose 4. So that would be 12C4. And when we type that in, we should get 495 different combinations of employees. Finally, there are 85 players on the football team. How many ways can the coach choose 3 to represent the team in the coin toss? So we are choosing from 85. We are going to choose 3. This is 85C3, which is going to give us 98,770 different possible combinations. All right, guys, that is all I have for you today. Thank you so much for watching, and I hope you have a great day.